Hello. All right. All right, question and answer. What would you like to know? How did this go? It's okay? Why is it so far away now? What did I do? I don't know what I did. You can unmute yourself so you can ask me questions as well, like with your voice instead of typing if you'd like. Sure. So let's do, so I want to wait. So this is lab. So yeah, we can do stuff, but this isn't an office hour. This is, well, let me think. Hold on. So for this lab, what I would like is like questions about like lab itself or like the class, and then I'm going to show you like how you're going to be doing the virtual like lab thing, and then after that I think that we can do like question and answer for the material itself. You know what I mean? Like, but I'd rather focus on like lab right now, questions. So do you have questions about the class? Yeah. Yeah, it looks like lab activity 8, lab activity 13, and homework 5 are due at midnight tonight. Yeah. And so you saw the file uploads are available there. So yeah, thank you for asking. Yeah, there's a quiz. No, wait, no, let's see. Do I have a study guide up? I don't believe that you do. And no, we don't have a quiz this week. And I want to remind everyone about your schedule, right? So this is still the detailed schedule. I got a lot of I don't know what that means. So what happened was that before I had got, oh my god, look, I have my I have before I emailed everyone. So I know you had lots of questions about when we're turning in things, and I hadn't said anything, and I was just like answering questions as they came in because I was waiting to figure it out. I didn't have a plan yet for how you would fill or turn stuff in. I figured it out, but before that happened, Sarah made those assignments available with submissions, and so even though she did it for just her section, it looks like my students also, it looks like everyone saw that there was something due, and then there was confusion, like, wait, like all of a sudden there's something due and I didn't know about it. But that, she only made it for her section, so I'm not really sure like why you saw it, but it was just a confusion, just, you know, with another instructor having her lab students like, you know, handing stuff in without me thinking about it for my students yet. So anyway, what was the question about that? Yeah, handing stuff in. So no, there won't be a quiz Wednesday. But the in-class quizzes will just be online too. They're going to be on Canvas, and you're going to have time to submit them given the feedback from the exam. I will be thinking about whether to make them open book or at least giving you more time, and perhaps starting like the availability of the quiz the night before. So just to give you more flexibility with that. Did those things sound good? Those were the suggestions that I got in the feedback for the online class. For you, oh yeah, so Gabby, it was your question about Lab 8 being graded but not submitted. So that's why, so did you, let me check, like you're saying that you did submit it, so let me see if I see it. Oh, Gabby, that's because you submitted it on paper. Figured it out. So Gabby, you submitted yours on paper, right? So I only had 2 that were submitted on paper, and so your grade is in there without having to have submitted anything. Yeah, exactly. Thank you. Other questions about the class and stuff? Or any of your, like, anything that's coming up for you? Anything that's not working or that you wish you had more support on? Yeah, so I'll show you. Hold on. You got a 0 on that activity 8. You don't have a 0 on that activity 8, you just haven't submitted it yet. Rhiannon. There's no 0. You shouldn't see a 0, you should just see that it's not graded. Is that true? Yeah, it's just not graded because you haven't submitted it yet. So like, I know that the due date for the labs came up, like for the submission came up quick, for homework 5 and for lab activity 8, but those were due before spring break. So like, I'm assuming that people had them done so that now they just have to submit them rather than it being a, like, totally out of the blue, even having them due. Like, you already knew they were due, so I'm hoping that just submitting them won't be too much of a time consuming thing today. I hope it works for everyone. So questions about homework 5, let's hold off on that. So I have open hours today. Someone asked about like the endo and exo examples, so I'd rather hold off on like content, like actual like open hours stuff until open hours today. But so the submissions are just on the assignment, so you just click on assignments. It's probably on your homepage too. So Eric, it's probably on your homepage where it says coming up, right? And it says like submit these things. That's probably like those assignments, and so you're going to submit them there. And then if you can't find them there, they are in the assignments tab. So either probably on your homepage where it says coming up, or in the assignments tab. Yep, definitely. Yep, on Canvas. Yep, yep, yep. Yeah, so you'll see them. Okay, good. Okay, so homework 5 you want to talk about later. More endo and exo we're going to talk about later. But for now, and then you were talking about lab today. So let's talk about lab today. You are doing a lab activity today. But remember, let me show you. I'm going to share my screen and show you the instructions for that. So here, oh, look. Oh, it's open for anyone. Okay, so what Sarah did actually was open up her lab for everyone to join live. So you're here with me. This is optional, question and answer. You can either then go to Sarah's lab right after this to get like a live instruction of how you're going to be doing lab activity 11, or you can wait until after her lab is over, after 12:30, to just watch the recording on your own time. So that's what we're going to be doing for lab today. I'll show you where, if you need to, like when, you know, if you need to go back and check it out, what you're doing for lab today. It's all in the announcement. Okay, so here, so Zoom attendance here right now is optional for me, question and answer. So now where it says for lab activity 11 credit, you can either watch Zoom recording posted, or it looks like she's allowing everyone to come into her lab. Yeah, it's recorded, exactly. Yep. Yeah. So you can either go to her lab after this, right, at 11 to 12, 11:10 to 12:30, or watch the recording later. It's on, it's all the Zoom stuff is all going to be, it's all under modules. Okay, so week 8 was the week before spring break. All of the recording, I say all, but there was just one lecture recording there. For week 9, there is going to be all the recordings for this week. Okay, here's the link for Francisco's SI sessions. Here's the link to sign up for the virtual chemistry labs, which I'll show you in a second. Here's the link for the 30A lectures and open hours and labs. So that's the Zoom and that's the recordings. So this is just the plan for today, Gabby. So we will be like doing it where what we'll be doing, it looks like, is Sarah and I and Will are going to be switching off in terms of who has the responsibility of like performing the lab live and recording it for students. And it looks like what we'll be doing is each time a different instructor has that responsibility, we'll be opening it up during their lab time for everyone. But if they can't make that lab time, then they can watch the recording later. So it's not that you need to wait until after to begin the labs. It's just that for Monday, that's when the recording today will be available. And as we're figuring this out, it'll be either you can go to the lab live if you can make it, or you can watch the recording later. Okay, thank you. Other questions? I wanted to show while I had my share screen up here, another more feedback that I was getting from students was wanting to have a clearer schedule. And the one that I'm still following is this one, right? Where we just had vacaciones de primavera, and now we're in Semana Nueve, right? And so we're still talking about chapter 6, right? Today is still lab activity 11. due at midnight tonight is still lab activity 13. So for lab activity 8 and homework 5, those were just pushed, you know, the due date was pushed till today instead of before spring break. And then on Wednesday, right, so Wednesday here, Monday here, we're still going to be finishing up the energy chapter. You're going to have a quiz, or no, excuse me, that's not true. You're not having a lecture quiz, pardon me. Yeah, you're not having a lecture quiz on Wednesday, but we are going to be finishing up endothermic and exothermic, or rather we are going to be doing lab activity 25, endothermic and exothermic. You will have online quiz 6 due on Sunday, right? So here's the Sunday column, and wherever you have the online quizzes. So I hope this is still okay. I know that you said you wanted a more detailed schedule, but this is still, you know, we're still going off of this. I'm wary of like committing to doing that for you because of all the extra time that it's taking me to make this class online and to all the other things that like have to be done to make it work. And so I'm like hesitant to commit to giving you a different schedule because it's all here and it's hard to commit to that time right now. Like, is there something, if I ever did get, you know, the chance to edit the schedule, what would you like to see included? And can you see me on the, you can see my little video and you can see the chat on the screen? Okay. So what else, like, you know what I mean? Like, it's hard to, like, to commit to making a new schedule, but it's all here. It's all here still. But when I say it's all here, that might not be good enough for people. So what would you like to see if I make edits? What would you like to see on the schedule differently or included? Okay. Okay, we'll keep trying to, yeah. Do you want to see a reference? Just the lab itself, I mean, there's always room on the lab. Like if you feel like you want to, you don't have to do your work on a separate paper. Oh, do you mean labs are turning in? Sorry. For lab activity 13, yeah, I do want to see the work. Yeah, for lab activity 13, probably, yeah. I would like to see the work. Yeah. Yeah, so turn in a picture of each of the pages. Yes, please. Yeah. Okay, do you want to see what your lab will look like? Do you want to see what the link looks like? Okay, cool. So, and again, you can go to Sarah's lab and she'll walk you through the actual lab itself or watch the recording later, but I'll show you what it'll look like. So the link is here to sign up for the virtual chemistry labs. The course key is Chem 30A. And it'll look like this. I already have an account, but you, right, course key students, you're going to sign up over here. And I'm sure that Sarah will be showing you this during the recording. And so the course key, register. And so you're going to register with your name, right, email address, etc., and sign up. And it shows you down here that you'll be registering for Chem 30A lab with me, Cabrillo College, right? The date started yesterday till the end of the semester. And so when you go in and sign up, you will see something that looks like this. You'll see the course most likely over on this side. This is what it looks like for me as the instructor, but I'm assuming that the students will also see like the name of the course. So this is it, Chem 30A lab. I'm gonna go to manage course. You're probably gonna see something like this. Oh, 15 are already enrolled, how excellent. And view syllabus is where you'll see the different units and modules. So on the syllabus, what you're going to be doing in lab for lab activity 11, and what's so cool is that Sarah found this. She said she spent so much time looking for like a way to do labs online, and she found this. And check it out, this lab down here in unit 7 is exactly what we're supposed to be doing in lab activity 11 today. So in module 22, designing hot and cold packs, that's what we're going to be using to carry out lab activity 11 for today's lab. Okay, so she's going to show you that whole thing, and that's what it'll look like. You can, yeah, you can. Definitely, if you want to. I think that like having instruction would be, I had to look at the help, but there is help. There is like a little help. So just like read. If you want to do it on your own now, that's fine. But yeah, and I can help you. I mean, that works, whatever you want to do. But I think that I'm going to stick to the plan mostly of just like letting students watch the recording with Sarah or go to her lab and do it then. Because this is an option, this is optional, so I just want to make sure that, yeah, that we're all on the same page. But yeah, you can go for it. Questions again? Other questions? Right, so this is all what we're talking about in the energy chapter, right? And you can, and the cool thing is too that you can use this on your own. Like that, now that you have this class, look, there's all, you know, there's equilibrium, which we're talking about next time, right? So you can do the labs in here that aren't, or the online activities, I should say, that we're substituting the labs for, like, right? We're going to be talking about solutions later, right, in this class. So a lot of the things are what we talk about in lab. So that can be useful to you just to learn more on your own. Okay. Are there other questions about the like organization of the course, the schedule, how it's going, what's coming up, before we talk about more endo and exothermic and homework 5? Okay. Well, what about, so what I would like to, I feel like, is answer questions. So wait, but was it Rhiannon who had questions about homework 5? Since that's due today, hold on a sec. Yeah, that's what I mean. Mobile Canvas like isn't, so I said that about the quizzes, but also it's for file submissions really is what it's all about. So yeah, so I would definitely use a laptop or a desktop whenever possible. Yeah, Wangchuk, lab 13 is due today at midnight. Yep. And okay, so Rhiannon, so Maya, are you still here, Maya? Let me check. Yeah. So Maya, let's get to more endo and exo after we talk about homework, because homework is due today. Is that okay if I go through and talk about homework 5 because it's, thank you. Great. So yeah, you turn everything in through assignments. So on the assignments tab, exactly, you'll see the assignment and the file submission option. So yeah, if it's not working on mobile, it's too bad. I mean, at this time of our lives in this coronavirus issue, I mean, like, they might be working on it right now. They probably are, but it's really too bad that it isn't working for file submission on mobile. So I'm sorry about that. Do the best you can. So homework 5, what did you have questions on homework 5? And you can turn on your microphone if you want. Yeah, 61. What, can you tell me the question? Like what? So I have second edition.
Hi, can you hear me? So it says, well, I have the 4th edition, and it says, how many grams are contained in 5 mole
Of each compound?
of each? Yeah.
Yep. Yep. Good. So did you get any of them, or do you want to work on, was it one of those, or was it the whole problem?
Let me see. So it looks like I just had a problem on D.
Cool. Like the answer that you had wasn't matching up?
Yeah. So I ended up doing like let's see. I think so. It says for D, aluminum, and then in parentheses, OH, which I'm having trouble remembering what that is right now, and then a 3. So I did 3 times H, and then I did 16 for O, and then I did 2698, and I added them, and I got 4601, and then I times it by 5.
Yeah.
Uh,
Cool, that's how you'd set it up, but it looks like the problem is probably in the molar mass, right? So you said AlOH3, so you did 3 H's, so this is for H. And this is the question in, so this is the question in the homework 5.
you
Where
know,
it says how many, I'm just telling everyone, yeah. This is the question in homework 5 where it says how many grams are contained in 5 moles of each compound. So in the second edition, it's number 65. In the 4th edition, it's number 61. So this is part D. Right, so this is for AlOH3. And so you have 3 hydrogens, right? How many oxygens are there?
just one?
Does
Or is
3 apply
it
to the whole thing?
okay.
Exactly. So that looks like it was what was making the discrepancy there for the answer.
Yeah, I think so, yeah.
Totally. So here's O. And aluminum has a molar mass of what?
26.98,
Okay.
I think. Okay.
So we've got 3.03 grams per mole and 48 grams per mole and 26.98 grams per mole. So that looks like it's the molar mass. And then the question was how many? So this is homework 5. Oops. How many grams in 5 mole of, and this one is for aluminum hydroxide. Yeah. So 5.0 moles, OO. And you want grams on top, so 78.01. So does that match up to the answer in the book, Rhiannon?
Yeah, that's it.
Wonderful. What is it?
It's 390 grams.
Great. Oh, was it 5.0? Oh, wait. 390 point?
It says the original one is 390.05, but in the book it rounds it to 390 grams.
390 with a decimal point, I hope?
Yeah.
Okay, good. For the 3 sig figs, right?
Yeah.
How did that work out for everyone else? Yeah. So 65 in which edition? And everyone, yeah, so 3 sig figs there, 390. Okay, so can you tell me, Ariana, if you want to put your microphone on, you can, or you can type it, which question is it? Because I have the 2nd edition. So wait, so for you, if that's 65, that's 2 down from this one. So how many molecules of butane? That one? Oh, the table sugar. Okay, yep. How many moles? Each number of grams. Yep. Great. Which one, was there one that didn't match up for you on the answers, or did you want to start from the beginning? Sure. So we've got grams. So we're starting with grams. Pardon me. And we're starting with grams. And so we need to get 2 moles, right? So can we do that with what is provided in the problem? So this problem is how many moles are contained in each number of grams of table sugar. Okay, so is everything in the problem that we need to go from grams to moles? Excuse me. Yeah. Great, so then we've got an A, let's see, we got 5.00 or 0.500 grams of sugar. And we need to perform a conversion sorry, I'm so blurry. There we go. Okay. And we have the molar mass of sugar, right, of sucrose. So what goes on the top here? Yeah. Does that make sense? Putting 1 mole on the top, right? Because that's what we're trying to calculate. So how many moles? In this many grams. And we've got, so we need 1 mole on top. And the molar mass is going to go on the bottom because that's grams, right? And so 342.3. And that's moles of sugar. 30 grams of sugar. And that's the molar mass. And so sugar is sucrose, right? Table sugar is sucrose, and it has that formula, that chemical formula, right? And so when we divide 0.5 by 342.3, what do we get? Can we get a third to confirm which one of those it is? Which one is it? Okay, great. Another 0 in there. Okay, good. So how many sig figs? Yeah, exactly. You got it. 0.00146. So that's what you do for all of those. This is just letter A. I was so much better last time. Probably because there's 2 zeros here, and it would have to be more digits. But again, it's okay. It's just probably that it's smaller for the answer. That is some scientific notation. But like the rule of thumb for what I've been teaching is that if it's smaller than 1,000th, so like if there was another 0 here, then you could put it in scientific notation. But it looks like they decided to put it in scientific notation, so that's okay. Either way. When it's small or large, you can put it in scientific notation. So what else? Any other homework questions since it's due today at midnight? Yeah, 19 version 4. So can you tell me the question? You can turn on your mic or type it.
The question for that one says, describe in section 5.AA, that is 302 to 203. What is the theoretical yield of O3 in grams from 324 grams of O2? And then B, what is the percent yield if the reaction actually gives 122 grams of O3?
Okay, cool. I think this was one of the questions that for the other versions, let me just share my screen, that for the other versions, the other editions of the textbook, that it was one of the additional problems. So let's go check real quick. Oh, sorry. Homework 5. Cool. Yeah. So in the second edition, it didn't have that question, so I added it down here. So you're talking about this one, right? Number 2?
Correct.
Right. So let's see. Okay, oxygen to ozone. Good. So what's the theoretical yield of O3 in grams from 324 grams of O2? So this is going to be like what we did with the worksheet, where you want to set it up with this little half pager, right? Where we had the original unit, and then you use the molar mass of the original, the mole ratio, the molar mass of the desired, and then you get the theoretical yield. So let's set it up that way. So I'll write it up on the board.
Do you mind removing this screen share and then just
Yes, let me just, yep,
Cool.
let me just get it up on the board so that I can
Sick, thank you.
have it. Wait, no, I guess I can do it I can stop my share and you'll see me, but you won't see what I'm looking at. There we go. Okay, so we set it up. So what do we need to know? What do we need to do first before we can proceed here? What do we need to calculate?
Would it be
Really, the
more
first
impact?
step is to balance the equation. So is this equation already balanced for you?
Yeah.
Yeah. Great. So that's the first step, is to balance the equation. The second step is to
Make a solution map.
we can make a solution map. That's true. That is the second step. Thank you. I forgot about that step. That is the second step. So good. So then, great. Our solution map will look like grams of what? Grams of?
O3.
What comes first? What are we converting from?
O2.
O2. Is everyone following along with that? And you can all turn your mics on if you want to. Right, because that's the original unit. So the grams of O2 is what we're starting with, and so that's the original unit. And we can convert from grams of O2 to what comes next?
O3.
Grams of O3.
Say it louder.
O3.
Okay, we can get to O3, but we have to go somewhere first. Like, can we compare rocks to feathers? Like, can we say that when we weigh, rocks compared to feathers, that we know how much there is of each? Like, right? We can't say, we can't compare rocks to feathers because they have different masses, right? Just like oxygen and ozone have different masses. So we can't go directly from grams of one to grams of the other. We have to go from grams of one to what unit?
Moles.
Moles, exactly. And what was the rhyme was like reach your goal, calculate moles, right? Reach your goal, calculate moles. So moles of O2, right? And then what can we do?
And then go back to grams of O2? Or no, grams of O3?
Okay. Is there a way that we can convert between moles of one thing and grams of another thing? Like directly. Is there a direct way that we can go from moles of one to grams of another?
We go to moles of O3.
Yeah, moles of O3. So like this is all good, right? To be able to calculate, to convert between moles, that can happen because that comes from the balanced equation. So this is saying that 3 moles of O2 react to form 2 moles of O3. So that, knowing that, tells us that we can convert between moles of one to moles of the other. We just can't go from grams of one to grams of the other because they have different molar masses, because they weigh different things. They weigh different amounts. So we can go from moles of O3 to grams of O3. And that's the desired unit over there. All right, so that's the solution map. You can go from grams of one to moles of that to moles of the other to grams of the other. And it's going to be that way for all these problems. Okay, and yeah, so then good. So we can set it up like this. You've got 324 grams of O2. And so now what do we need to go from grams of O2 to moles of O2?
We need the molar mass of O2.
Exactly, the molar mass of O2. So let's calculate that. So we've got two oxygens that each have a molar mass of 16. So the molar mass of O2 is 32 grams per mole. So what goes on the top? Grams or moles here?
Well,
Moles.
so we wouldn't use 16, we'd have to use 32 just because there's 2 of the oxygen.
Yeah, because the molar mass of O2 is 32. Mhm.
Okay.
Right, we always have to use, and this is just related to the problems that we were just doing before. We were calculating the number of moles of sugar for the number of grams of sugar. So using the molar mass of sugar was required, just like using the molar mass of oxygen, O2 is required. Now what do we use? What's the next part called? The next conversion factor.
The moles of O3.
What was it?
O3, 1 mole of O3. Or 3.
Yeah, what's it called? What's the next conversion factor called?
Mole ratio?
Yeah, the mole ratio. And that comes from the balanced equation. So I'm going to use blue to show that it comes from the balanced equation. So how many moles of O2 react to form how many moles of O3? So how many moles of O2 do we write in the ratio?
2.
Yep. And do 2 moles of O2 go on the top or the bottom here? Oops, yeah, top or bottom here?
Bottom?
Okay, let's check it out. So we've got moles of O2 on the top here. And remember that the next conversion factor will always have what's in the top on the bottom in order to cancel. Right, we need to cancel out moles of O2. So actually the 2 or the 3 moles of O2 will go on the bottom so that moles of O2 can cancel. Do you see that?
Mm-hmm.
Up top, the mole ratio of what we are aiming to calculate, right, is 2 moles of O3 for every 3 moles of O2. And this is how we can compare apples to oranges. This is how we can compare rocks to feathers, right? Even though O2 and O3 have different masses, they weigh different things, we can compare the two together, which is what we're trying to do here, to figure out how much of one we can get from a certain amount of the other. We can compare them when we know the ratio in which they react, like the ratio of one to the other. The mole ratio tells us that for however many of one, we get however many moles of the other. So that's what we're using here to compare apples to oranges. So moles of O3 need to be on the top or the bottom now for the next conversion factor.
On the bottom?
Uh-huh. And that's going to be, and what are we going to use in this next conversion factor? What's that called?
Molar mass desired.
Yeah, the molar mass of the ozone. And what's the molar mass of ozone?
Would it be just 16 times 3?
Yeah, 16 times 3, exactly.
Should be 48.
48 grams of O3. And that's the molar mass of O3. And that'll give us the theoretical yield, so the number of grams of O3 that can be produced theoretically in a perfect world, right, from this many grams, right, 324 of O2. We can't just say that from that many grams we get this many grams without going through the mole ratio, because they have different weights. They weigh different things, they have different molar masses, therefore, and so we have to use the mole ratio. So, what do we get?
2,916.
2,916?
I got 324, but the book says 323.
Way off. Ugh.
Okay, so let's show you how to go through it on the calculator. Okay, so the way you can punch this in is 324 divided by 32 times 2 divided by 3 times 48. So what did you get?
I got 324.
324. So in this case, this is a special case because check it out. The fact that it's O2 to O3, right? And they're balanced where, right? We've still got the molar mass of O2, right? Times 2, and the molar mass of O3 divided by 3 tells us that overall it will be a 1-to-1 gram ratio, so it's still going to be 324 grams of O3. It won't, that's like the one instance where, like, I don't even know if I've seen like other reactions where you'll get the same number of grams based off of the mole ratio and the molar masses. It's just special because it's just O2 reacting to form O3 here.
I'm not sure why the book says 323, but
Right.
I'm not sure either. The book says 323.
yeah, it's kind of weird. I don't
That's
know.
weird. It might have been the different molar masses with more sig figs, maybe.
Yeah, who knows?
Yeah.
Are we able to do B for that one too?
Yeah.
'Cause that one's a percent. The B ends up being a percentage.
Right. Right. So the percent yield is equal to what over what?
Gabby, do you have it up on your book? Because I can't find it in my book, number 19.
I don't have it in my book. What do you mean you can't find the what part?
Just the question, because
It's on page 174 and division 4.
okay, fine. Okay. Um, okay.
So what goes on top? What goes on bottom?
I don't know. Gabby, do you see the numbers?
One more
So
time?
it says, sorry. It says problem 5.919. Is problem 5.19. What page is it on, Gabby? Do you both have fourth edition?
Yeah, it's 174, and it's right above 5.9C.
Oh my god, I can't find it.
Feel it.
On the same, you're both, are you sure you have the fourth edition? Maybe you don't.
Yeah,
And it's on page what?
174.
You can show-
174.
You can show me your page if you want.
Oh, I don't have a camera.
Okay.
Gabby, did you find the problem?
Yeah. I'll send you a picture.
Well, could you read the numbers?
Specifically for the grams?
For like 19B?
Oh yeah, it's right here. It's on the board. So what is
Yeah.
the percent yield if the reaction?
Oh, that's the one oh,
Mhm.
sorry guys.
No problem.
Okay.
So we're just continuing here, yeah. So this is a, right here. Oop. And this is part B. What is the percent yield if the reaction gives 122 grams of the O3 ozone? So what goes on top?
Actual yield,
Yeah, which is?
122 grams.
Yeah. And on bottom?
The 324 grams.
Grams cancel, you multiply by 100%.
Mm-hmm.
And what do you get?
The 37.6%?
Oh,
Or do you round that up to 37.7? But they have 37.8 in here.
yeah, because of their theoretical yield, right, which was 323.
Yeah.
Yeah, I'm not sure about, I must have been the molar masses. They might have used more sig figs in their molar masses. Yeah, that's probably what it is. They used more significant figures in their molar masses. But the ones that we use have fewer. So what was it, 30?
37.6.
I rounded it up to 37.7 just because the 5 at the end of it.
Yeah, 37.7%. Yep. Awesome.
I also had a question on 71, C and D, if nobody else has questions.
Yeah, let's open up and see if other people
Yeah.
would like to, yeah, thank you, would like to pipe in. What other questions do you have? You're doing lab activity 11. Either you can go to Sarah's lab, which is posted in the announcement at 11:10 and do it live with her, or you can wait on your own time and do it from the recording. Does that make sense, Lyle? So either at 11:10, you can zoom in to Sarah's lab with her link in the announcements, or you can do the lab from her recording, which will be posted after. Okay. Good. Other questions? Okay, so then, so Maya, well, I wanted to, so Maya had questions about endo or epso, but are you still here, Maya? Okay, cool. So Maya can come back to open hours. So what question was it, the next homework question? Yeah, definitely. So great. So let's do the one, well, actually, Rhiannon, do you mind if we go to Ariana's question, then we'll go to yours after?
Yeah, that's fine.
Okay, so Ariana, so the butane one. Okay, great. Let's do the butane question. Homework 5. And Ariana, you're 4th edition? Okay, 67, 4th edition. And for me, $69. Okay, so was there one that you didn't get the same answer as the book, or did you want to start from the beginning? Okay, so let's see how many molecules are butane in are contained in the following number of moles. So molecules of butane from So for the first one, there are, if we have 2.00 moles, and we need to get to molecules. So is there a way that we can go from moles to molecules? Right, where molecules are desired and moles are original. So what can we use to convert from moles to molecules?
Avogadro's number.
Avogadro's number, exactly. And so Avogadro's number lets us count the number of particles, right, in grams or moles, right? So Avogadro's number, right? We got moles, so what's gonna go on top, right? Avogadro's number is 6.02 times 10 to the 23rd. That's really hard to see, sorry. Particles per mole. So that's what we're going to use here. So is it going to be moles on top or particles on top? Moles on top or molecules, I should say.
Molecules.
Yeah. So 6.02 times 10 to the 23rd. Oops. Molecules. For every 1 mole. So when you multiply that out, 2 times 6.02 EE23 if you have an EE button. So what do you get for the number of molecules? And let's make sure everyone gets this in their calculator. Yeah, and how many sig figs? What's the final? Yeah, what's the final rounded answer there? Yeah. And does it make sense that it's a really big number? Yeah, right. There's a whole lot of molecules in 2 moles of butane, right? And so, yeah, so we just multiply, right, the number of molecules in a mole times 2, because we're talking about 2 moles. And great. Yeah, good. And so you can do that each time. You're welcome. And what was your question, Rhiannon? And by the way, like for our open hour today, we can totally go over the exam. I think that'd be a good idea. I hope that people come to open hours to talk about the exam. But what was your question on the homework, Rhiannon?
It was 71 in version 4 of the book.
Yep.
So I was understanding how for A and B, they start out as they're asking about mold. So I got those ones. I was confused when it started showing I guess scientific notation form. So on number C, it's asking that the question says, what is the mass in grams of each quantity of lactic acid with the molar mass 90.08, the compound responsible for the aching feeling of tired muscles during vigorous exercise? And so C says 7.3 times 10 to the 24th molecules.
I'm sorry. I thought that I would. Oh, wait, which question? I'm so sorry. I thought that I knew which question it was, and I'm so sorry that I.
That's okay. It's 71 in the 4th edition.
Yeah, and tell me the question.
It says, what is the mass in grams?
Ah, perfect. It's 71 in mine too. Okay.
Okay.
So.
And it's
Okay,
just
so which letter?
C.
As in.
Like 7.3 times 10.
You said the letter though was something as in what? B as in boy, D as in dog, C as in.
C as in cat.
Okay, thank you. I couldn't tell. All right, so then, yeah, so molecules. Great. So can we go from molecules to grams? Are we able to go right from molecules to grams?
I don't know.
Let me show you the graphic that I posted here. I think I mentioned it briefly one day when we were like preparing, talking about the exam review. But let me show you. Here you go, the helpful mass moles molecules flowchart. So can we go directly between molecules and grams?
It says no.
Right. Where do we have to go? What is the middle unit? Like, what's the middleman? I don't want to say middleman because I don't want to be gender specific, but what's
Is
the
it
middle unit?
from molecules to Avogadro's numbers to moles? Or and then to molar mass and then to gram?
Right, so molecules so you use Avogadro's number to get to what unit?
To moles.
Good. And then to what unit?
To grams.
Yeah, good. Molecules to moles to grams. So you can do that.
Okay.
So that can be helpful. That's in the study part for exam 2. So molecules to moles to grams. That we can do. So it's asking for 7.3 times 10 to the 24 molecules. So what goes on top? Or I should say what goes on bottom.
1 mole.
So we can think of this as all over 1. That's over 1. So what needs to go on the bottom here?
Is it Avogadro's number?
Exactly.
Okay.
So 6.022 or 6.02 times 10 to the 23rd molecules. And what goes on top?
1 mole.
Good. And we were talking about lactic acid. So did it give you the molar mass? It did give you the molar mass. 90. Yeah. So what goes on bottom now?
The 90.08.
Okay. If we did 90.08, that would be grams for every 1 mole. Will that work out?
Oh, no, wait. No, you have to put the 90 on top.
Exactly. The 90.08 grams goes on top for every 1 mole on the bottom.
Okay.
And that's how you set it up.
Okay. Let's see.
So how many grams is that?
Shit. I'm still trying to do it on the calculator. I messed up. 24 divided by 6.2, 10.
So I ended up with over 1,000, but I had to round it down to 1.1 times 10 to the 3rd. Is that because of the 7.3 times 10 to the 24th?
Is what because of that?
The scientific notation.
That's for the reason we were talking about before, for the fact that it's more than 1,000.
That makes sense.
Right? So being a bigger number, you can express it in scientific notation. You don't have to. I mean, if I asked for it, you can. You don't have to. Did you get the number, Rhiannon?
Almost.
What are you getting?
I just kept messing up and typing in the wrong numbers. Okay, so I got 5.821 to the 52nd power.
Okay. So you're dividing. So make sure you type this in. So 7.3. Do you have an EE button?
Yeah, so I did the 7.3 and then 10, 24, but then I divided it by 6.02. Is that right?
Hold on. Do you have an EE button?
Yeah.
Okay, so you did 7.3 EE 24.
Oh, I thought we're supposed to do the times button, 10, and then EE.
Uh-uh.
Oh.
EE means times 10 to the.
Oh.
Mm-hmm.
Uh,
So, yeah. So EE means,
Go ahead.
yep. So 7.3 EE 24
Okay.
divided by 6.02 EE 23
Okay.
times 90.08.
Okay, so I got 7.974 to the 27th.
Okay, so try it again. Let's do 7.3 EE 24
Okay.
divided by parentheses 6.02 EE 23 close parentheses
Mm-hmm.
times 90.08.
Now I got 1092.3.
There you go.
Okay.
So it looks like you have to do parentheses on your calculator, okay?
Okay.
Okay. So then that's either 1100 in 2 sig figs or 1.1 times 10 to the 20 or times 10 to the third grams of lactic acid. Right? So 2 sig figs. Okay, so the people that I haven't heard from, I'm glad that you came. Thank you for being here and getting your question, or getting at least, seeing how some questions are answered. And so I'll see you in open hours back at same time as it usually is, same place.
Okay.
Same place, same bat channel. Same time, what is it? Same time, same bat channel.
Okay, I don't think I'll be able to make
channel.
it.
Same
to
Zoom
open hours.
channel is what I meant to say. What?
I said I don't think I'll be able to make it to open hours.
Okay, well, I'm glad you came now then.
Yeah, thank you for all your help.
You're welcome. Thank you. Thank you, everybody. See you soon.
Okay.
Bye.
Have a good one. Bye.
Yeah. Bye.